A fan network can be electrically alive and still be completely silent. The usual reason is not a bad fan. It is a mismatch between layers, power, RS-485 signaling, serial framing, Modbus addressing, or the fan's own register map. In this walkthrough, we will build one network from the physical fan outward, then use a disciplined 5-check sequence to find the first broken layer. Start by separating energy from information. Mains power runs the motor and must follow the exact safety and product drawing. The RS-485 pair carries differential communication, it does not power the fan. A separate analog or PWM input may also exist on the same EC motor. One Longwell drawing shows all of these interfaces together, which is precisely why the model and protocol revision must be locked before any wire or software setting is copied. Now draw the bus as a line, not a constellation. One controller sits at one end of a twisted pair trunk. Fan nodes attach with short derivations as the trunk passes them. A star creates multiple signal paths and reflections, especially as cable and bit rate increase. Termination belongs at the two physical ends of the transmission line when the system design requires it, not at every fan. Cable impedance, transceiver guidance, biasing and shield treatment all remain project-specific. Every node on that segment must agree on the serial grammar, baud rate, data bits, parity, and stop bits. A single mismatch makes a healthy electrical signal look like nonsense. Modbus RTU then frames each message with an address, a function, data, and a CRC error check. The silent interval between frames also matters. Think of the CRC as a seal on the envelope. It detects corruption, but it cannot repair wrong wiring, wrong timing, or a wrong register. Give every fan a unique slave address. The master asks one addressed node a question, and that node answers. Slaves do not normally talk to one another. Address 0 is used as a no-response broadcast in the selected protocol, so it is a poor first commissioning tool. Begin with one fan, one known address and one conservative read. Only after the response is stable should you add the next node and record its identity. Function codes describe the operation, while the fan manual defines the meaning. A read-holding register request may retrieve target speed, an input register request may retrieve actual speed or status, a write single register request may change a command. Those are examples, not promises. Modbus protocol addresses start at 0, while manuals and software sometimes display references differently. Always reconcile the tool, function code, offset, scaling, signedness and byte or word order. Use reads before writes. First request an identity or clearly defined status value, then actual speed, voltage, current or fault bits if the exact map provides them. Compare the raw response with the manual scale. A plausible number is not proof, a swapped byte order can still look believable. Keep a commissioning table with device address, protocol revision, function, register offset, raw value, conversion and expected engineering unit. When a write is finally justified, bound it. Confirm that guards and airflow paths are clear, choose a safe command, define what happens if communication is lost, and verify the return state plus the physical result. Do not assume that receiving an echo means the fan obeyed. The selected product protocol includes target speed, restart and direction-related fields, but those addresses and behaviors belong only to that family. Remote starting remains a controlled machine safety action. If there is no reply, debug from the bottom up. Check power and fan identity, then the differential pair and reference strategy, then termination and topology, then baud, parity and stop bits, then node address, function and register. Watch the controller's timeout and CRC counters. Reversing A and B blindly is not a method because A, B, plus and minus labels are not consistent across vendors. Follow both exact manuals and verify the pair de-energized. If one fan works but the full chain fails, look for a network effect, duplicate addresses, long stubs, an unintended star, excessive or missing termination, a loose shield or reference path, common mode voltage, noise coupling, or a power problem that appears under load. Add nodes one at a time and keep the last known good configuration. That turns a building-wide mystery into one controlled change. A handover file is as important as the working demo. Record the fan and firmware or protocol revision, controller and transceiver, cable and route, termination locations, shield and grounding design, serial settings, node list, register map version, polling interval, timeout, retry policy, safe fallback, tested commands and measured results. Save the exact configuration and label both physical ends of the trunk. Here is the final commissioning order: exact documents, safe power installation, bus topology, serial grammar, unique addresses, read-only proof, bounded rights, loss of communication behavior, and a recorded as-built file. A good Modbus fan network is not created by one magic register. It is created when every layer agrees, and when the next technician can prove exactly what was installed.